Hello there. In today's lecture, let us discuss about the simultaneous equation. So before we get into the solving different kinds of problems, let us just try to understand what is simultaneous equation. So when we talk about simultaneous equation, when we have more than one equation, and we have more than one equation, and when we also have more than one variable. So more than one equation and more than one variable or unknown, anything you can call it, that's when we know that we are dealing with a simultaneous equation. So generally it could be in terms of x or y, a and b, or even more than two variables is also possible. So I think you kind of get the idea. So generally there'll be two unknowns or three unknowns, and you could be given some conditions or you could be given some equations, and you're expected to find out the unknowns. So in those kind of situations, we use simultaneous equation. Now, before we proceed into solving it, the simultaneous equations can be solved in multiple ways. Like for example, we can use elimination to solve it, and we can also use substitution to solve it. So right now, in this particular lecture, we'll try to look at the elimination method. So when we try to eliminate something, we are trying to get the we're trying to eliminate one of the variable so that we'll be able to find out the value of the other variable, and then try to find out the value of the variable which we eliminated in the first place. So that's one way to think. Let me just write it again. We have elimination method, and we also have the substitution method. So when we talk about the substitution method, in that particular situation, when we what we do is we find out, we make one of the variable as a subject and we substitute in another equation to get the value of that variable, and then we can also find the value of the remaining variable. So that's the substitution method. But right now, let's try to focus on the elimination method. And even when we talk about the simultaneous equations, there are two more segregations. One is the linear simultaneous equation, and we also have the quadratic one. There could be higher powers, but this is what is in our syllabus, simultaneous equation. So there could be a linear simultaneous equation, there could be a quadratic simultaneous equation. So an example of a linear simultaneous equation would look like, let's say we have something like x plus y, we have something like x plus y equals to 4 and x minus y equals to 3. So this is an example of a linear simultaneous equation in which the highest power of the equation is 1. Then we can also have a quadratic simultaneous equation like x square is y plus 2, x plus y equals to 4, something like that. I'm just giving out the equations at random. So this is an example of a quadratic simultaneous equation because one of the equation, the highest power is 2. So we have linear simultaneous equations, we have quadratic simultaneous equations as well. So what we do is we start with the linear simultaneous equations in today's class. We go through the elimination method, and then the next class we'll try to go through the substitution method. And once we are comfortable with the linear simultaneous equation, that's when we try to solve the quadratic simultaneous equations. I hope that's clear. So let's try to start with the elimination method for the linear simultaneous equations. So before I begin, I just want you to look at this particular question. I'm just giving you an example: x plus y equals to 3 and x minus y equals to minus 1. So we have a linear equation in front of you, and I want you to just try to think about it. Even if you are aware how to solve it or you're not aware how to solve it, I just want you to think about it and try to solve it on your own. Just give it a try. Yeah. So I hope I hope you have given it a try. Even if you didn't get the answer, that's totally fine. So what I'll try to teach you is, I'll try to teach you the elimination method. So when we're talking about the elimination method, what happens is we're trying to eliminate one of the variable. So we're trying to get rid of one of the variable. So we can get rid of x or y. So once we get rid of the one of the variable, it becomes a linear algebraic equation with a single variable, and I think most of you are already aware how to solve that. So let's take this as an equation number one, and we have equation number 2. So when we have equation 1 and equation 2, we can try to eliminate one of the variable. So what we are trying to do right now is, let's try to add 1 plus 2. So when we are adding both the equations, if you can observe, x plus x would add up to x plus x would add up to 2x, and y and minus y would add up to 0. They cancel each other out because they are the variables with same value but opposite signs. Because they have same value and opposite signs, they cancel each other out, and 3 and minus 1 would add up to 2. Now we have a single variable equation. It's very simple. We divide 2 on both sides. We will be getting x equals to 1. That's the value of one of the variable. I hope that's clear. So once you get the variable, you can just try to take it, and we'll try to substitute in any of the equation. Let's say we're trying to substitute in the equation 1. So in equation 1, x plus y equals to 3, and we already know the value of x is 1. So we substitute that here, and y would be 3. We subtract 1 on both sides, y would come out as 2. So the value of x is 1, the value of y is 2. So let me quickly recap what we have seen. We have two equations, and we have two variables. We want to find out the value of x and y. So we have found out that the y has same value in the sense that it's 1y and minus 1y. The value is still the same, but the sign is different. So in that kind of a situation, we can just simply add the equations. And when we simply add the equations, the y would get eliminated, and you have the value of x. Then when the y would get eliminated, we get 2x equals to 2, and then x equals to 1, and then we can find out the value of x, and then we can also find out the once we get the value of x, it's pretty simple. We can find out the value of y. So that's the elimination method of one of the example. So what I'll try to do is I'll try to give you another example. Uh, let's try to find it out. So let's say we have x plus y equals to 4, and so we have x plus y equals to 4, and x plus 2y, let's give x plus 2y equals to 5. So x plus y equals to 4, x plus 2y equals to 5. So we have the equation. Maybe you can just give it a try. I hope you have given it a try. You can pause the video and give it a try. I hope you have given it a try. So we have this is the equation number 1, and that it would be equation number 2. Okay. So just try to think about it. You want to eliminate one of the variable. Let's say if you want to eliminate y, is it possible to eliminate y? It's not, because they don't have the same value. So by adding or subtracting, we would never be able to eliminate y in first place. But let's look at x. Both are x's, and they have the same values. So when we subtract them, we can eliminate x. So when we subtract 1 minus 2, what we'll be getting is x gets cancelled, y minus 2y would be minus y, and 4 minus 5 would give you 1. Minus 1, sorry. So minus y equals to minus 1 once you get the value. So that means y equals to 1. So once you get the value of y, half of your work is done. Then we can substitute in any of the equation. So we can take y equals to 1 value, and we can substitute in any of the two equations. Let's say we want to substitute in the equation 1. Equation 1 is, let me use a different color. Equation 1 would be x plus y equals to 4, and we know that x y value happens to be 1. So x plus 1 equals to 4. That means x equals to 3. So we have y equals to 1 and x equals to 3. So sometimes we need to add equations, sometimes we need to subtract. We need to do whatever is necessary to get the missing, to eliminate one of the variable and then try to find out the other variable, and using that we'll try to find out the initial variable. I hope that is clear.